So we learned about the for of loop to loop over arrays, which remember is an iterable, but we can also loop over objects, which are not iterables, but in an indirect way. Now we have different options here depending on what exactly we want to loop over. So do we want to loop over the object's property names, over the values, or both together? And let's start by simply looping over property names. And so remember, they are also called keys. Now ultimately we will still have to use the for of loop to loop over the array, but again we're going to do that in an indirect way. So we're not actually looping over the object itself. Instead, we're going to loop over an array. So let me show you how. So I'm going to call this day, and you will see in a moment why. And now of, and then I say object.keys, and we pass in the opening hours object. And now let's simply, to see what happens here, log the day variable to the console, and then I will explain what happened here. So indeed we get Thursday, Friday, and Saturday, which are exactly the three key names of the object. So we can see that here. So indeed, Thursday, Friday, and Saturday. So let's take a closer look at this mysterious object.keys. And let's do that here before actually. So let's just say properties equal object.keys, and then again opening hours. And now I want to take a look at the result here. And so indeed, it is an array with the three property names. Okay, and we can actually also use this to now compute how many properties are in the object. So let's say we wanted to print a string saying how many days the restaurant is open. That would be simple, right? We can just log to the console. We are open on, and then properties dot length. And now we get the number of properties here, of course. And so that's 3 days. Okay. And so this is also the array that we're going to be looping over. So properties. And that's why I called this variable here day, because this array basically contains 3 days. Now let's actually do something cool here and instead store this into a variable. And let's say open, and then str for string, and here a colon, because now using the loop, I will basically keep adding to this string. So open string plus equal, and then the current day. So day, and then a comma. And so here we are then essentially building just this string. So that's similar to something we did already before. And so the end is we are open on 3 days: Thursday, Friday, Saturday. Great. So that's property names. Let's write that here. Okay, but what if we actually wanted the property values themselves? Well, then we would simply use object.values. So let's also store this here. And of course, then we need to pass in the object itself. So that's again opening hours. Missing the equal sign. And now let's just take a look at the values. And indeed, these are exactly the 3 values that we specified right here. So this value here, right? So open 12, close 22, this one and this one, right? So before we had the keys, now we have the values, and there is no need to now loop over them again because it's going to work exactly the same as here. Okay? But now, to really simulate to loop over the entire object, we actually need the entries. And so entries is basically names plus values together. And we already saw the entries before. So when we looped over the array, and I think that's going to be somewhere down here. Oh, and actually I already passed it. So indeed, here it is. So here on the array, we called this entries method. And so the entries return the index number and the element itself. And so we can do something similar on objects, and that will then also return the key and the value. Okay, now it works differently on objects because it's not going to be a method that we call on the object itself. So here we had the menu array, and then we did that menu array dot entries. But now here we do it differently. So we use again object dot entries, and then we pass in once again the opening hours. So this distinction between the array and the object is important as we loop over the entire object. Okay, I actually run into that problem myself at some point. So that's why I'm telling it to you. But anyway, let's store this again into a variable. And so then you have all the three versions here nicely organized in your code. And let's take a look here at the entries now. And so as you might have expected, we now get an array. So all of these keys, values, and entries basically transform the object into an array. And then here we have first the key and then the value. All right. And so now we can use this to basically loop over the object. So for, and now let's start by writing the of. I will just call it x for now, and then we will take a look. So x of the entries that we just generated, and then let's just log them to the console. And so let me get rid of this one here. All right, so that's weird. Oh, it's because, of course, I want to log x. Oh yeah, that's correct. So now we have each key and each value. All right, now we want to print to the console a string like this. So on the weekday, and so that is the key. And so I'm using these variables here before I actually defined them. So to make it easier to say what we want to define. So for example, on Friday, we open at, and then we're going to have an open variable and close at close. So how will we do this? Well, just like we did with the arrays, we can use this structuring right here. So let's do that. The first one is the key, and remember the second one is the value. So we could do this, but we already know that this here is an object, right? And so therefore we can also immediately destructure that object here. So fair enough, open and close. So the two variable names inside of that object are open and close. And so here we specify exactly these property names, and so they get destructured. And therefore this works. So let's see that again. And so, yeah, so this is here the value, basically, all of this, right? And so here we have open and close. And so that's exactly what we defined here as well. And therefore we then end up with the string here, which got all of the data out of the object into this nicely and neat string. All right. So this part here is necessary because the value itself is also an object. But if you had a more simple object with a simple value, then you would of course only do this here as destructuring, just a key and a value. And of course you could then give them other names as you would like. So here we can just call them day. We can use any name that we want. Awesome. So we're doing great progress here. And now it's time to practice that once more. So I see you in the next coding challenge. Let's challenge ourselves with coding challenge number 2. And in this one, we're going to continue with our football betting application. And let me start by saying that this challenge is actually a bit difficult. All right? But that is on purpose. So after all, it's called a challenge. And so you should really challenge yourself with these exercises. Otherwise, it could be called a coding copy and paste, right? So please try your best to solve these, and you can try the problem-solving framework that we talked about earlier. And of course, you can also use Google, MDN, and so on and so forth. Okay? But with that out of the way, let's get into the exercises. And the first one is to loop over the game.scored array, and then print each of the players to the console along with the goal number. So this one is not that hard. And so let's just, so the object is down here. So we're going to use the same object, all right? So this is the array that I was talking about. And so here, in this case, we should print Lewandowski goal 1. Then here, goal 2, Gnarby, goal 3, Lewandowski, and goal 4, Hummels. Okay. Then number 2, use a loop to calculate the average odd and log it to the console. And we already studied how to calculate averages, and so you can go check that out if you don't remember. And here you should actually directly use the object itself. So don't destruct the object first into variables and then use that to calculate the average, but instead really calculate the average of the elements in the object. Okay? Then number 3, I want you to print the 3 odds to the console, and do that in a nice formatted way, like you can see it here. Now here, you're not allowed to hard code the names of the teams, all right? So instead, get them directly from the game object itself. Now, of course here, except for draw, because that's nowhere in the game object. So as a hint, I have here that the odds and the game objects have the exact same property names. And so you can use that knowledge maybe to get the name of the teams here. So these are the 3 exercises for this challenge, but then I also have a bonus. Now let me just tell you that I will not solve this bonus question in this video because it would take me a little bit too long. But I will still put the solution in the final code of this section, so in the GitHub repository, so you can check out the solution there if you attempt to do this bonus. So this one is really hard, and what I want you to do is to create an object called scorers, which will contain the name of the players who scored as properties. And so Gnarby, Hummels, and Lewandowski were the players who scored in this game. And as a value for each of the properties, we want the number of goals. All right. So this means Lewandowski scored 2 goals and the other 2 players scored just 1 goal each. So this is a little bit difficult again, but you can do it. Well, at least with some research and with some reviewing of all the material of the course so far. Anyway, good luck with this challenge. Take your time, and I see you once you're ready. All right. Hopefully you did at least 1 or 2 of these exercises. And so here goes my solution. And keep in mind once more that my solution might be different from yours, but that's totally okay as long as yours produces the same result. So here the goal is to score over the scored array and print all of the players to the console. So const, and let's again fix that later, and then of game.scored, and now we actually want the entries. All right, and we want the indexes because we also want the number of the goal. Remember? So goal 1, 2, 3, and 4. Okay, and so entries will give us that. And so now we just need to destructure that into the index and then the player. Okay, actually we don't even need the curly braces. Let's just say console.log and then goal, then the index +1 so that it starts at goal number 1, and then simply the player. Let's take a look. Oh, and now we have the problem here that I'm accessing game before it is initialized. And so the problem is that the game is down here. So I will have to take this game object now to that other challenge. So let's just cut it from here and put it here. So now it should work. And indeed, we get the 4 goals nicely printed to the console, exactly in the order in which they appear here. All right, next one. And in this one, we have to calculate the average odd. So the average basically of these 3 numbers here. So what we're going to do is to loop over this object here and simply add all of these 3 values together and then finally divide them by the number of elements here. And so that's how you calculate an average. And so we start by creating the average and set it to 0. And so again, we already did that before, I believe. And so now we can loop over the object such as I explained it to you before. Const odd of. And now what do we actually want? Do we want the keys or the values or both? Well, in this case, we are really just interested in the values, right? And so this object.values will give us an array essentially containing these 3 values. So we need to say game.odds. Okay, and now in each iteration, we will simply add this odd to the average so that then in the end we can divide it by the length of this object.values array. So let's do that. Plus equal the current odd, and then finally average divided equal, and so this is a new one, by object dot values game dot odds, and then let's log it to the console. So this one here means basically average is equal average divided by this here. And this is actually the same as up here. So let's refactor it into, let's say, simply odds. And then let's use that here. Odds and odds. And we have a problem. So let's do some debugging here. I will start by taking a look at the average after it is computed here in the array. So average. Oh, so here we have a number, which means that something is wrong here in the division, right? And I see it's because we need to write odds.length. Okay, and so then it will be the number 3 in this case. So before I was dividing by the entire array, and that doesn't make any sense. And so now we should see something close to 4 here. Yeah, so 3.7 essentially. And so that's our result. Okay, and you can go over this code here again if you need to understand it even further. But now let's move on here to exercise number 3. And this time the goal is to print basically the content of the object to the console. So we're going to loop over that. And again, I will first say what we need here actually. So we want to print both the team and the odd. So we need the entire object. And so, just as we learned in the previous lecture, we use object dot entries of game.odds. Okay, and so we know that we get an array of arrays, which in each position will have both the team and the odd. All right, so let's say team and odd. All right, and so here it is us who define the variable name because it is now an array. So we don't have to match any property names. And let's start by simply logging both to the console team and odd. Okay, and so indeed, we already have that kind of working. We already have the team here, and we have the 3 odd values. Now what we want to do is to create a string like this. Let's actually copy this so we know what we have to do. And by the way, here, notice again what I explained to you in the last lecture, how in the array we use the entries method to get the entries of the array, but in the object we have to use object.entries and then pass into the function the object that we are interested in. So that's fundamentally different, so keep that in mind. Okay, so here we now want to build a string like that. So odd of victory Bayern Munich, draw or victory Borussia Dortmund. And so here we're going to need some more logic. Let's just put here some dots. And now here the odd. So the odd is the easy part. So we have that one already finished. But now here we need some more complex logic. And actually let's create this part of the string. So like victory Bayern Munich or Borussia Dortmund or draw. Let's create that here in a separate value. So let's call this one team string. And so here what I'm going to use is to use the ternary operator. Okay, so I will say that if the team here is X, like we have it here, then the string should become draw. And so that will then create this here. So team equals X, then the result should be draw. But if not, then we need the team name itself. So how will we get that? And remember, there was a hint about this. So note how the odds and the game objects have the same property names. And indeed, here we have team 1, team 2, and here we have team 1 and team 2 as well. And so here are the team names. And so let's now get these team names using these keys that we already have here. So we want the string victory. And then we go to the game object and team. Let's check. Now I know, of course, we need to put that string here. So team string, and it works. Beautiful. So let's just recap this part here. So here we go into the game, which is the entire game object, and we take the property team. But team is already this property name here, right? So it's team 1 or team 2. And so then we take that to read the property with the same name from the game object. And so therefore we get Bayern Munich and Borussia Dortmund. Okay, great. So this one was a little bit more tough, but we managed to do it in the end. Now again, I will not create the solution for the bonus, but you can always find it in the final code of this section. And with that being said, let's now go back to learning some more JavaScript. In the past, JavaScript has always had very little built-in data structures. So basically, we only had objects and arrays. But in ES6, 2 more data structures were finally introduced. And that are sets and maps. So these are pretty common data structures that already exist in other programming languages, and now they also exist in JavaScript. So in this lecture, let's learn all about sets. And a set is basically just a collection of unique values. So that means that a set can never have any duplicates, and that property makes them useful in certain situations. So let's create a new set here. Let's call it orders set. Okay. So again, to create a new set, we write new set, and then here we need to pass in an iterable. And the most common iterable here is an array. So let's create an array with a couple of strings now. Let's say pasta, pizza, then pizza again, then risotto. Let's put another pasta and another pizza. Okay, so 6 strings, but of course they could be different data types in here. So set can of course hold mixed data types. That's not a problem at all. Now here we clearly see some duplicate strings. So what do you think that this set will look like now that we created it and when we log it to the console? Well, we get a set. Here we can see it has a size of 3, and the only values that are in there are pasta, pizza, and risotto. So that's right, all the duplicates are actually gone. Now also we can see that a set kind of looks similar to an array, right? So there are no key value pairs, it's just a bunch of values grouped together, in this case, into a set. And just like arrays, sets are also iterables, okay? Now, of course, a set is still very different from an array. So first, because its elements are unique, and second, because the order of elements in the set is irrelevant. And we will see why in a second. But anyway, keep in mind that strings are also iterables. So we can do this. So we can pass in a string. And so now we get a set with these 5 elements. So, and that's the 5 components basically of this iterable, which is this string. And of course, the set could also be empty, just like this. All right. And now let's learn how to actually work with sets. So first off, we can get the size of a set. So order set dot size, and so that is 3. And so in this particular example, this might be useful for the chef of our kitchen to know how many different meals are going to be cooked here, right? So if this array here is an array of all the orders, then the set of these orders are simply the unique different meals that are going to be cooked. And then the size is how many different meals will be cooked. And just note how it is actually called size and not length like it is in arrays. So don't make that confusion. Next, we can check if a certain element is in a set. So order set dot has, and so this is actually a method. And so let's check if pizza is in there, and let's check if bread is in there. So true and false, and that's exactly as we expected. And so comparing again to arrays, this has method is similar to the includes method in arrays, right? Next up, we can also add new elements to a set. So order set dot. So let's say that now someone ordered garlic bread. And let's say that this actually happened twice. So what do you think that the set will look like now? So order set. And so the garlic bread got added, but only, of course, one of them. Because again, the set has to be unique. And so the second one was basically ignored. Finally, we can also delete elements. So let's do that before the log. So order set.delete. So all of these method names are very straightforward, and that's because this is such a modern feature. So the modern stuff really has these more straightforward names and a different way of working with the data structures. So we have risotto here, and so now here we are deleting it, and so indeed it is now gone from the set. So really, really easy. And in arrays, there's actually no method that is this simple. We will see how to delete elements from arrays later, but I can tell you that it's a little bit more complex. Okay, and that's actually it. But now you might ask, how do we actually retrieve values out of a set? Can we maybe use an index like in arrays? So doing something like, maybe like this here. And the answer, as we will see, is no. So this doesn't work. It gives us undefined, no matter what number we put here. All right. And that is because in sets, there are actually no indexes. And in fact, there is no way of getting values out of a set. And if we think about this, then it makes sense. So there's really no need for getting data out of a set. That's because if all values are unique, and if their order does not matter, then there is no point of retrieving values out of a set. All we need to know is whether a certain value is in a set or not, and that's why we have the has method. If your goal is to actually store values in order and then retrieve it, then the best use case is to just use an array. You wouldn't use a set for that. And so again, there's no need for getting values out of a set, because if you need it, then you would just use an array. Finally, there is actually one more method here, but it's not that important. All we can use it for is to basically delete all of the elements of the set. And so we see that now it is empty, right? But let's put that back so that we can work some more with this set. So as I said in the beginning, sets are also iterables, and therefore we can loop over them. So let's say order from orders set, and not from, it is off, obviously. And then we can just log the order, and indeed, here they are. So looping is possible just like in any other iterable. All right, so now that we know how to work with sets, let's see a big use case for them right now. So in a normal code base, the main use case of sets is actually to remove duplicate values of arrays. So let's just write that here, example. So let's say that we have an array in our restaurant which contains the stuff of our restaurant. Let's say we have one person that is the waiter, one person that is the chef, another person that is a waiter, then we have also a manager, then we have another person that is a chef also, and another waiter. So that's an array of all our stuff in the restaurant. But now let's say that for some reason we are interested in knowing only which different positions there are in our restaurant. Or in other words, we would basically like to have a unique array of this, right? So this array without all the duplicates, that will solve the problem. So let's create a set for that. Easy enough, right? So stuff unique equals new set, and then the iterable that we need to pass in is the stuff, because an array is already an iterable. Now this is not yet the end of the solution, but let's take a look at it for now. And of course, it needs to be stuff unique. And so, yes, So we have a set now with waiter, chef, and manager. So the 3 unique positions. But now we actually want this to be an array. But the conversion from a set to an array is pretty easy because they are both iterables. So remember from earlier that the spread operator works on all iterables, right? So that includes sets. And so we can now create an array around this basically, and then we can unpack this entire set here using the spread operator, and then these elements will be put into the newly constructed array. Okay? And so indeed, we now end up with a new array. Okay? So the spread operator here works just like on an array. It works really exactly the same. So it takes all the elements out of the iterable and essentially writes them here like comma separated, right? Now, if we only wanted to know how many different positions there are, then the size property is very useful. So all we would have to do, even though this looks a little bit weird, would be to say new set, then with the array, and then dot size. And that's it. And then we wouldn't even need to have to create the array at all. So if we didn't need the unique array. So if all we had was this, and we wanted to know how many unique positions there are, then this here would be the way to go. And the same could even be done with counting how many different letters there are in a string, right? Because an iterable, or actually a string, is also an iterable. So let's see how many different letters there are in my name. And it looks like there are 11. All right. So, as a conclusion to this video, sets are not intended to replace arrays at all. So whenever you need to store values in order, and that might contain duplicates, always just use arrays. That's also true when you need to really manipulate data, because arrays have access to a lot of great array methods that we're going to study a little bit later. Now, sets have this very useful property of being unique. And it's also very easy to interact with sets by using all of their straightforward methods. However, they are not nearly as important as arrays. So keep sets in mind when you need to work with unique values, but besides that, you can just continue using arrays. So we learned about sets. Now it's time to learn about the other new JavaScript data structure, and that is maps. And let me start by telling you that maps are a lot more useful than sets. So what exactly is a map? Well, it's certainly not the same thing that we use in the real life to find our ways around. No, instead, in JavaScript, a map is a data structure that we can use to map values to keys. So just like in objects, data is stored in key value pairs in maps. Now the big difference between objects and maps is that in maps, the keys can have any type, and this can be huge. So in objects, the keys are basically always strings, but in maps, we can have any type of key. It could even be objects or arrays or other maps. So that can lead to some really great and advanced stuff. So let's create a restaurant map here. So I'm just calling it rest here. And so we again use the constructor just like we used for the set, but this one called map. And the easiest way to create a map is to actually create an empty map just like this, without passing anything in. And then to fill up the map, we can use the set method. And then here we pass in 2 arguments. The first is the key name. So let's call it name, and then the name of the restaurant itself. So Classico Italiano. And so you see that this set method is pretty similar to the add method that we had in sets. So both allow us to add a new element to the data structure. And remember that we can use any data type that we want. So let's say that the restaurant has 2 locations. So we can create a key with a number. It doesn't have to be a string. So let's say one is in Firenze, Italy, and the other one, so a number 2, is in Lisbon, Portugal. And calling the set method like this does not only update the map that it's called on, but it also returns the map. So let me show that to you here. Okay, so this is what the set looks like after adding this key number 2. So here we have the entries. The first is name, which is then mapped to Classico Italiano, and then the other 2 that we just added. Now, the fact that the set method actually returns the updated map allows us to chain the set method like this. So let's set categories here as an array, and I will just grab that from up here. Okay, so once more, the value can be anything. And now I can just chain the next set on here. So I can now say open and set it to 11. And then again, I can chain the next one and say close at 23. So let's save it. And this will then format this nicely. So again, calling the set method returns the updated map. And so all of this is now the updated map. And so we can call set again on that map. And we can continue this even further. So let's now actually even use Booleans as the key here. And we can say that we want to map true to we are open. And then we can also set false to we are closed. And we will see in a minute how this can become useful. Okay. Now, in order to read data from a map, we use the get method. And so that get method is available on all the maps. And so all we need to do is to pass in the name of the key. So let's see. Let's log this to the console actually. And let's just duplicate it here and also log true. And you see that the true key here is then mapped to we are open and named to Classico Italiano, of course. And here, when we get the elements, of course, the data type of the key matters. So if we tried true the string, then that would be undefined. And if we tried to retrieve 1 as a string, that would also be undefined, because here we have 1, the number, as the key. And so with this, we will then get Firenze, Italy. All right. Now, just for fun, let's use the fact that we can have Boolean keys. So this true and false here, right? And we also have the open and the close time. So you see they are all kind of related. And so let's create something fun with this. So let's say we have some current time, and we could actually get the current time from JavaScript, but we don't know how yet. So let's just say it's 21 hours. So that's 9 p.m. And then we could do something really clever like this. So rest.get. And so when we pass in true, then we will get we are open. And when we pass in false, we will get we are closed. And so in order to get the correct string here according to the time, all we need to do is to compare the current time with these two open and close. Okay? So let's do that. We can say, or we can ask, is the time, so the current time, greater than rest.get open? And at the same time, is it below rest.get close? So basically here we are asking if the current time is between 23 and 11. And so this here is a true-false value, and this is a true-false value, so a Boolean. And so the result of this AND operation will be either true or false. And then true or false will map to one of these values. So that's really clever, right? So let's log the result to the console. And let's check it out. And so at 21 hours, we are open. And that makes sense. It is between these two times. But if it was like 8 hours, then we are closed. Amazing. Now this is, as I said, pretty clever, but it's not really so readable. So don't overuse this kind of pattern, okay? This just really goes to show the power of having Booleans as map keys. But anyway, let's now keep exploring the methods that are available on maps. So we already have methods to set and to get. Now we can also check if a map contains a certain key. So let's log to the console the result of calling the has method. So categories, and so this should be true. And it is indeed true. Then we can also delete elements from the map, and again, that happens based on the key. So rest.delete, and let's say that the second location should be closed now. So this one here, the one in Lisbon. And so we take that key and delete it from the map. And as a result, that will then be gone here. So you see, no longer there. Now comparing this to objects, we can actually also delete properties from objects using something called the delete operator. But that's a really slow process, and usually it's not encouraged to do that. Here about the has method, actually objects do also have a method, which is called hasOwnProperty, but we're going to talk about that in the object-oriented programming section. All right. Next, maps also have the size property. So rest.size, of course, and that should be 7, as we can see here. And yeah, so it has 7 items. And then to finish, we can also clear, so basically remove all the elements from the map. Let's just put that here. And so now it's gone and it has a size of 0. Let's put that back. So as you can see here, there is some overlap in the way that we work with maps and sets. And that's because they were both introduced in ES6. And now just to finish, let me show you that we can, in fact, use arrays or objects as map keys. So let's here set something else. And so now as a key, I will use this array. And I will set it to test. Okay. And let's just put that actually here, so it's before the log, so we can take a look at it. And so here indeed we see this is now the key, this array. All right. But now to get the data based on that array, let me see how we could do that. So rest.get, and think about what we are doing here. Do you think that this will work? And actually we need to log it to console. But given what we learned in the previous section about how JavaScript works behind the scenes, especially primitives versus objects, do you think that this will now retrieve test? Well, let's see, and no, it did not. And the reason for that is that these two arrays are actually not the same object. So this array and this one, even though we wrote them in the same way, and so they have the same elements, they are not the same object in the heap. Okay? And the key here is exactly this object in memory, and not this one. And so this cannot work. In order to make it work, we would have to do this. Creating an array, 1, 2, and then we use that array. And then we also use the same array to read the value out of the map. And so now it is gonna work. Okay, because now, of course, these two refer to the same place in memory. Great. And so with this, we proved that we can indeed use objects as map keys. And this can be very useful with DOM elements, which in fact are also nothing more than just a special type of object. Let's do that here as well. Let's do rest.set. And now as a key, we will use document.querySelector. And then we're going to select this h1 element that we have here. So this is just an h1. So nothing fancy. And so the result of this will be an object. And so let's say that this is the heading. And now as we check it out here, you will see that it is here indeed. So as I hover it, you can even see it here visible on the web page. You see that? The highlight up there? That exactly is the key of this map entry. Sounds crazy, but it is possible, and it can enable some advanced functionality. All right, so we learned here how to create maps and how to work with them. So this should be enough for one lecture. And so let's wrap up this one now and continue learning about maps in the next one. So let's continue learning about maps. So in the last video, we created an empty map and then added elements to it by using the set method. Remember? However, there is actually another way of populating a new map without having to use the set method. And I prefer that because the set method is a bit cumbersome when there are a lot of values to set. So instead, we can create a new map like this. So I'm going to call this one question, because now we're implementing something like a quiz. So in a very simple way. So new map. And then here we can pass in an array. And this array itself will contain multiple arrays. And in each of these arrays, the first position is going to be the key, and the second position is going to be the value. So let's do that. So let's say question, and then what is the best programming language in the world? So this is basically the first entry of this question map. So before we would have used the set method and then this as the first argument and this as the second. But now we can simply specify this array of arrays in this way. Now, next up, I want to specify the options for the answer, basically. And so I can simply do that by their number. So the first answer is going to be C. So C, the programming language. The second will be Java. And the third will be, of course, what else? JavaScript. Then we need a key for the correct answer. And what do you think the correct answer is? Of course, number 3. And then we can also have like a success message and an error message. And so let's again use the Boolean keys. So true, which is basically when the user is correct, then we can say correct. And maybe some kind of emoji here, like this one. But if it's wrong, so if the answer is false, then try again. All right. And so let's take a look. And that looks correct. Fantastic. So when creating a new map from scratch directly in the code, I actually prefer this way of writing it over the way that we did in the previous lecture. But when we keep adding new elements programmatically using code, then of course the set method is still the way to go. Now, as an aside, does this kind of structure here, so this array of arrays, look kind of similar to you? Well, I hope it does, because this is exactly the same array structure that is returned from calling object.entries. So for example, on the opening hours object. And so you see that there too, we get an array of arrays, where the first element is the key and the second one is the value. And so what this means is that there is an easy way to convert from objects to maps. So let me write that here actually. Convert object to map. And so we can say hours map is a new map. And then simply with object.entries of opening hours. All right. So again, because this structure that results from object.entries is exactly the same as this. So an array of arrays. So indeed, now we have a map here. And so keep this small trick here in mind whenever you need a map when you already have an object. Next up, let's talk about iteration. And iteration is possible on maps because, as we already know, maps are also iterables. And so the for loop is also available for them. And so let's use a for loop actually to now print just these options here to the console. So these three, all right? So as always, I like to start with first saying what we will loop over. And so that's going to be the question map. And so each item of the question will, just like before, contain both the key and the value. And so here I can now directly destructure that into two separate variables. So this is a really, really good use case of destructuring. All right. So just to reiterate, this is exactly the same as we did when we looped over the object. The only difference is that for the object, we needed object.entries right here. And that's just because the object is not an iterable. But then we converted it to an iterable using object.entries. And so then this part here is exactly the same. Okay. Now keep in mind, we only want to print these three. So essentially, we only want to print an element if the key is a number. So let's use what we already know. Type of key equal number. And only then log to the console. So inside here, answer, and then the key. So the number for the person then to choose with the correct value, which is going to be the answer option itself. So here we go. Answer 1, 2, 3. And now let's just also log the question itself. So quiz app. And here we want question.get, remember, and then the question key. And so now it is complete with question and answers. Now to get the answer from the user, let's again use a prompt. So answer equal prompt. And let's ask for your answer. And answer. And remember, we need to convert this now to a number, because eventually we will compare this number with the key that we have here. All right. Let's just print it then also. Okay, so here we have the question, and of course the correct answer is number 3. And so here we go. And now we can use the power of the Boolean keys here in order to print either the success message here or the error message, basically. All right. So do you think you can do that on your own? Just take a minute or two and try that on your own right now. So did you manage to do that? Well, let's start by comparing the answer with the correct answer, basically. So that is question dot get correct. And so this is 3, right? And then we can compare that to the answer. So in this case, this was also 3. And so this here would return true, correct? And now, since this is true, we can directly plug that into the map. And so this true will then return correct. So that's similar to what we did in the previous video as well. And so again, we are using the power of having Boolean values as keys. And then let's just log that final message to the console. So 3 again. Oh, and something went wrong. But I see that it's just here. It's the name. So this is correct, not correct. So again, 3. And now indeed we get correct. Okay. So this is 3 here. The answer is 3. This is 3. And so this here will be true. And so when we get true from the map, we get this string. Now, something else. And indeed, we get try again. Okay, and with that, we finished this nice little quiz. Now, just to finish here, as a side note, sometimes we also need to convert a map back to an array. So basically to this structure. And we can do that like this. So convert map to array, basically. You can do that by simply building a new array and then unpacking, again using the spread operator, the question map. It's asking us here again. And so then the result is essentially this same data structure, so the array of arrays with which we started. So it's this one here. So in this case, of course, this wouldn't make too much sense, but it's still good to know that sometimes you can convert a map to an array. Let's just preset this here to some value so that it doesn't always bug us here. And by the way, there are also the methods that we had on arrays, which are the entries and also keys and values in case that you need them. Okay, now they give us this weird iterator here. So then, just as I showed you before, you have to spread them and put them in a new array. So like this. But this is not really that important. I just wanted to show you that this exists. And for this, there's actually no need because it's going to be exactly the same as this one. Okay, so these are all the keys and all the values indeed. All right, and that's all I have to show you about maps for now. But now you might be wondering, when should I use maps and when should I use objects? Because they are pretty similar, right? Well, that's what the next lecture is all about. There, I will help you to choose between all the data structures, including even arrays and sets. Dealing and working with data is the main thing that we do as developers. And that's the reason why, since the beginning of the course, we have been working with JavaScript's built-in data structures like arrays and objects. Then in the last few lectures, we learned about two new data structures, which are sets and objects. So now we have 4 data structures from which we can choose. And so I decided to create this quick lecture which will show you the pros and cons of each data structure and also when to choose each of them. And I want to start this video by quickly categorizing where data can actually come from. So there are essentially 3 sources of data. First, the data can be written within the program's source code itself, like status messages that will be displayed on a web page based on user actions. Second, data can come from the user interface, so from the web page. It can either be data that the user inputs into some form, or data that's already written somehow in the DOM. For example, this can be the user's tasks in a to-do app, or expenses in a budget app, or anything like that. Finally, data can come from external sources, which is usually a web API. Now, what is a web API? Well, API stands for Application Programming Interface, and we can basically use a web API to get data from other web applications. For example, we can use a web API to get the current weather in any city, or data about movies, or currency conversion rates, and really every kind of data that you can imagine. And we will learn how all that works later in the course. So no matter where the data comes from and what kind of data it is, we usually always have collections of data that we then need to store somewhere. And so where do we store collections of data? That's right, we use data structures. But as you know, there are 4 built-in data structures in JavaScript. And so now we need a way of deciding between them. But it's not that hard. So the first decision is this. Do we just need a simple list of values? If so, then we're going to use an array or a set. But on the other hand, if we need key value pairs, then we need an object or a map. So the big difference here is that with a key value pair, we have a way of describing the values, so by using the key. On the other hand, in a list, like an array or a set, we simply have the values without any description. Okay? Now, as a quick example, let's go back to getting data from a web API, because in modern JavaScript applications, that's usually the most common source of data. So data from web APIs usually comes in a special data format called JSON, which looks like this example here. So JSON is essentially just text, so a long string, but it can easily be converted to JavaScript objects because it uses the same formatting as JavaScript objects and arrays. So here we have 3 objects that describe recipes. We have the values in green, like the title and the publisher, and it makes complete sense that these values are then described using a key. Otherwise, we would have no idea what the different values actually are, right? So key value pairs are essential here, and that's why this data is stored in an object, not an array. Now, each of these recipe objects in itself can be seen as a value, and since we have many of them, it means that we have again a collection of data, and therefore we need a data structure to store them. Now, do we want to describe each of the objects? Well, it's not really necessary, is it? We already know they are all recipes, and whatever information we need about the recipes is already stored right in each of the objects. So all we want is basically a simple list where all the recipes are held together. And so here, an array is the perfect data structure for that. And in fact, creating an array of objects is extremely common in JavaScript. Now you will be working with this kind of data all the time as a professional JavaScript developer. And that's why I'm placing so much focus on this here. Okay, now before we move on to compare arrays, sets, objects, and maps, I quickly want to mention that there are also weak sets and weak maps data structures in JavaScript. Also, there are even more data structures that are used in programming, but which are not built into JavaScript. And just to mention a few, these can be stacks, queues, linked lists, trees, or hash tables. And these don't really matter for now, but I still just wanted to let you know that there are more than just the 4 built-in data structures. But now let's talk a bit more about the built-in data structures. So you already know at this point how to use all of them, but it's important to know when to use them. So starting with arrays versus sets, we already know that we should use them for simple lists of values when we do not need to describe the values. Now, you should use arrays whenever you need to store values in order and when these values might contain duplicates. Also, you should always use arrays when you need to manipulate data, because there are a ton of useful array methods. Now, sets, on the other hand, should only be used when you are working with unique values. Besides that, you can also use sets in situations when high performance is really important, because operations like searching for an item or deleting an item from a set can be up to 10 times faster in sets than in arrays. Now, one great use case for sets is to remove duplicate values from an array, like we already did before. So sets are really not meant to replace arrays, but rather to complement them whenever we are dealing with unique values. Okay, so now let's talk about objects versus maps, and we already know that we should use these key value data structures whenever we need to describe the values using keys, right? But when to use objects and when to use maps? Well, objects have been the traditional key value data structure simply because we didn't have maps before ES6. But using objects simply as key value stores has a couple of technical disadvantages. And that's why some people say that we've been abusing objects for this. Now, maps, on the other hand, are way better suited for simple key value stores, because they offer better performance, in fact. Also, map keys can have any data type, and they are also easy to iterate, and it's easy to compute the size of a map. However, the biggest advantage of objects is probably how easy it is to write them and to access data by simply using the dot or the brackets operator. Also, most developers are already super used to objects, and so they simply keep using them for simple key value stores. Anyway, as a conclusion, you should use maps when you simply need to map keys to values, and also when you need keys that are not strings, because as we saw in the last video, that can be very powerful sometimes. Now, if you need functions as values, then you should absolutely use an object for that. So in objects, these functions are then called methods, and you can use the this keyword to access properties of the same object, which is impossible in maps. Also, when working with JSON data, as we saw in the previous slide, you will probably be using objects for that as well, unless you then want to convert the objects to maps. But that's usually not something that we do. So, in fact, we still use objects all the time, but maps are also a very important data structure right now, and way more important than sets. Great, and with that, we wrap up this overview. I hope you found this useful, and so let's now move on. And now it's time for coding challenge number 3. And we are still working on our football betting application. Now this time we have this map down here, so this one, which contains all the events that happened during the game. So the values here are the events themselves, for example a goal or a substitution, and the keys are the minutes in which the event occurs. And just notice that a football game has 90 minutes plus some extra time. So this might be a little bit over 90, but usually it's always 90 minutes, in case you're not familiar with this beautiful game. Anyway, your tasks are to create an array called events, which will contain all the different game events that happened during this game. And that means no duplicates in that array. Now, after the game has finished, it was found that the yellow card from minute 64 was unfair. So please just remove this event from the log. Next up, print this string to the console. An event happened on average every 9 minutes. And of course, your task is to calculate this 9 minutes, keeping in mind that the game has 90 minutes. Finally, loop over the events and then log them to the console. And what's tricky about this is that you should mark whether they happened in the first half of the game or the second half. And the second half means that it happened after 45 minutes. So it should look something like this. So I believe that this challenge is a little bit easier than the previous one. And so hopefully you can manage to complete all of these 4 tasks. So I see you once you're done. So I hope that was fun. So let's get started immediately with the solution here. So we should create an array called events with the unique events. So basically, that's the unique values of all of these here. Now, what are these values here? They are essentially the values of this map, right? So what I'm saying is that they are game events dot values. And we learned about this one kind of by the end of the last video. So let's comment out this one here. And so indeed, we see that this is what contains the values that we are interested in. All right. So let's say game events dot values, and this is our starting point. And now to get the unique values here, we basically need to create a set out of this, right? That's the main use case of sets. So, new set, but this alone is not going to be enough, but let's still take a look at this for now. And beautiful. So indeed, we have a set with the only 4 events that happened. So there were only golds, substitutions, yellow cards, and red cards. And now, to convert this to an array, we do it just like before. Create a new array and the spread operator to unpack this set, and then we are done. Next up, this one is the easiest one. So it tells us to delete the event from minute 64. So that's very easy. So game events dot delete. And now all we have to do is to use that exact key, and then that event will be gone. Great. The next one is just as easy, I believe. So let's just grab this from here. And now we just need to calculate this actual average. And how do we do that? So basically, to say that an event happened every X minutes, we simply need to divide the number of events by 90 minutes. So the duration of the game. So we see here that we have 3, 6, 9, 11 events. So how can we count that programmatically? Well, for that we have game events dot size. Remember? And now we just divide that by 90. And with that we get this weird number. And that's because, in fact, we need the opposite. So we need to say 90 minutes divided by how many events there happened to say that on average something happened every 9 minutes. Now, if we wanted to be really specific, then this game actually lasted 92 minutes. So how do we get that value? So this is just a bonus. Okay, I didn't expect you to do this one. So this 92 is essentially the last of the keys of the map. So let's get the keys. So that's game events dot keys, and as always we need to convert this to an array. So using all the tools that we already learned. So just to make sure, indeed it is. And now we want the last value. And how can we get the last value? Do you remember that? Well, we can use the pop method. And in the past, we mainly used the pop method to simply delete the last element of the array. But also back then I told you that this also returns that deleted array. Or actually that deleted element. And so here we can take advantage of that. So this here is an array now. And so on that we can call pop. And so that will take the last element out of the array and give it to us. So that's 92. And so to make this really accurate, here we can now say time. Okay, and so this is even better right now. But again, this is just kind of a bonus just to show you some more nice little tricks. Anyway, now our goal is to loop through the object, or actually through the map. And so this is pretty standard now at this point. Now here we are missing the off. So just like we did in the last video. And now all we need to do is to figure out the half. So if it's the first half or the second half. So what we want to log to the console is this. And then so either first or second half. And then the minute, I believe, let's see. Yeah, so the minute and then colon and then the event. So let's actually make these here more specific. So minute and event. So that makes it easier to read the code. So minute and event. And now here let's just again create an external variable, which I'm going to call the half. And let's use the ternary operator here again. So if the minute is below or equal 45, then it is the first. Otherwise, it's the second. And that's it. And that worked just fine once again. Okay. So I hope that made sense. In case it didn't, then as always, just analyze the code, or you can also just ask some questions in the Q&A area. Anyway, we're now almost done with this section. Next up, all we have left to do is to work with strings, which is also a really nice and really interesting topic that we need in JavaScript all the time. So make sure to follow me there right away.